Hello everyone. In this video we are going to talk about the combustion process. A fuel is basically a source of heat. The usual method of producing heat from fuel is by the process of combustion. And combustion is a chemical reaction between the fuel and the oxidant. The combustion equipment is a component of the steam generator. Since the source of heat is the combustion of the fuel, a working unit must have whatever equipment is necessary to receive the fuel and air proportion to each other and to the boiler steam demand, mix lignite and perform any other special combustion duties such as distillation of volatile from coal prior to ignition. So the combustion efficiency actually depends on various factors. Freely ignited fresh charge of fuel, then steady combustion for obtaining the desired amount of heat release, adequate combustion space, quantity of air supply for complete combustion, the method of air supply. All these factors affect the combustion efficiency of a combustion equipment. Combustion equipment include heaters, ovens, stoves, furnaces, fireplaces, dryers, strokers, burners, and many more. Now, fluid fuels are handled by burners, solid lumps fuels by strokers. In boiler plants, hand firing on grate is practically unheard of nowadays in new plants. Although there are many small industrial plants still in service with hand firing. Okay. The fuels are mainly bituminous coal, fuel oil, and natural gas, which are mentioned in the order of their importance. All are composed of hydrocarbons, and coal has as well as much fixed carbon and little sulfur. To burn these fuels to the desired end products, CO2 and H2O requires air in the sufficient proportions. Then it also requires a good mixing of the fuel and air. It also requires a turbulence or a relative motion between the fuel and air. The combustion equipment must fulfill all these requirements, and in addition it should be capable of it should be capable of close regulation of rate of firing the fuel for boilers which ordinarily operate on variable load. Coal firing equipment must also have a means for holding and discharging the ash residue. Now there are certain basic requirements of combustion equipment, such as thorough mixing of the fuel and air is required, then optimum fuel air ratios leading to the most complete combustion possible maintained over full load range, ready and accurate response of rate of fuel feed to load demand, usually as reflected in the boiler steam pressure, then continuous and reliable ignition of fuel, practical distillation of volatile components of coal, and adequate control over point of formation and accumulation of ash when coal is the fuel. So all these are the basic requirements of any combustion equipment. See, natural gas is used as a boiler fuel in gas well regions where fuel is relatively cheap and coal sources comparatively distant. The transportation of natural gas over land to supply cities with domestic and industrial heat has made the gas in the well more valuable, and the gas fired steam generator more difficult to justify in comparison with coal or fuel cost alone. Cleanliness and the convenience in use are other criteria of selection, but more decisive in small plants in central power stations. Transportation costs add less to the delivery price of the oil than gas. Also, fuel oil may be stored in tanks at a reasonable cost, whereas gas cannot. Hence, although fuel oil is usually more costly than coal per kg of steam generated, many operators select fuel oil burners rather than strokers because of the simplicity and cleanliness of the storing and transporting the fuel from storage to burners. Okay. uh, then let us talk about the fuel firing system. The firing system is mainly classified into two categories, which is called as hand firing and the stoker firing. Okay, hand firing is very simple method of fuel firing. The combustion efficiency is very low when it is compared with the other. Due to lower combustion efficiency, this hand firing method cannot be used in the modern power plant. Okay. Now this hand firing is very simple method of firing, and it requires no capital investment, and it is used for smaller plant. As I said, adjustments are to be made every time for the supply of air when fresh coal is fed into the furnace in case of hand firing. Okay. There are hand fire grades available in hand firing method, which are used to support the fuel bed and admit the air from the combustion. So while burning the coal, the total area of the air opening varies from 30 to 50% of the total grate area. The grate area required for an installation depends upon various factors such as its heating surface, the rating at which it is to be operated, and the type of fuel burned by it. Okay. The width of the air opening varies from 3 to 12 mm. Here you can see that the air openings are given. The construction of the grate should be such that it is kept uniformly cool by incoming air, and it should allow ash to pass freely. Okay. Hand fired grates are made up of cast iron. Then another type of firing is called as stoker firing. A stoker is a power operated fuel feeding mechanism which is using grate also. This method of firing is used for burning solid coal on a grate. The stokers are also classified under two categories as overfeed stoker and underfeed stokers. Okay, so in this slide you are going to see the detailed classification of the stoker as overfeed stoker and underfeed stoker. Then this underfeed stoker can also be classified as single retort stoker and multi-retort stoker. Overfeed stokers can also be classified as traveling grate stoker and spreader stoker. Traveling grate stokers are again classified into two categories as chain grate stoker and bar grate stokers. So this is a detailed classification of the stoker firing system. Now let us talk about the overfeed stokers. But before talking about the overfeed stokers, let me explain that a stoker is nothing but a power operated fuel feeding mechanism and grate. It is a combination of a fuel feeding mechanism and a grate. Okay. There are various advantages of stoker firing, that it has a cheaper grade of fuel can be used in case of stoker firing, then higher efficiency is attained, greater flexibility of operations is assured, then less smoke is produced, generally less building space is also required, and then stokers can be used for small as well as large boiler units also. Okay. Practically, there is a reduction in the auxiliary plant. Then the capital investment as compared to pulverized fuel system is also less in case of stoker firing. So this stoker firing, it is classified, these automatic stokers are actually classified as overfeed stokers and underfeed stokers. So in overfeed stokers, the coal is fed into the grate above the point of air admission, and in case of underfeed stokers, the coal is admitted into the furnace below the point of air admission. So this is the major difference between underfeed stokers and overfeed stokers. So let's talk about the overfeed stokers in detail. So in the overfeed mechanism, a forced draft fan slightly pressurizes the atmospheric air before it enters under the bottom of the grate. Okay. So the fuel bed receives the fresh coal on top surface. The ignition zone lies between green coal and incandescent coal. The air gets heated up as it follows through the grate opening, where as the grate gets cooled, this warm air gets additional heat energy by further passing through a layer of hot ashes. So this is a diagram. You can see this is the principle of an overfeed stoker shown with the help of this diagram. Okay. So here you can see that at the bottom the grate is shown, over the grate there is ash and incandescent coke, then this is the green coal, and these are the flames which are generated after burning this coal. Okay. So to this flames the secondary air is given. Okay, now the fuel bed section receives, this is a fuel bed section which receives the coal on the top of the surface. The ignition planes lies between green coal and the incandescent coal. Okay. The air with its water vapor contained from atmosphere enters the bottom of the grate. This is the primary air. You can see it enters the bottom of the grate, and in flowing through the grate opening the air is heated while it cools the grate. The warm air then passes through a layer of hot ashes and picks up the heat energy. So this is flowing through the layer of hot ashes and it is picking up the heat energy. The region immediately above the ash contains a mixture of incandescent coke and ash, coke content increasing in upward direction. As the air comes in contact with incandescent coke, the oxygen reacts with the carbon to form carbon dioxide. Water vapors entering with the air reacts with the coke to form CO2, CO and free H2. Upon further travel through the incandescent region, some of the CO2 reacts with coke to form CO. Hence, no free O2 will be present in the gases leaving the incandescent region. Okay. The fresh fuel undergoing distillation of its volatile matter forms the topmost layer of the fuel bed. Heat for distillation and eventually ignition comes from various sources, such as by conduction from the incandescent coke below, from high temperature gases diffusing through the surface of the bed, then by radiation from flames and hot gases in the furnace. Then they also come from the hot furnace walls. The ignition zone lies directly below the raw fuel which is undergoing distillation. To burn the combustible air gases, additional secondary air must be fed into the furnace to supply the needed oxygen. The secondary air must be injected at considerable speed to create turbulence and to penetrate to all parts of the area above the fuel bed. The combustible gases then completely burn in the furnace. Fuel, coke, ash in the fuel bed move in the direction opposite to that of air and gases. Raw fuel continuously drops on the surface of the bed. The rising air feed cools the ash until it finally rests in a plane immediately adjacent to the grate. Okay. Now there are this is a more clear picture of what we have seen over here. So this is shown with the different colors. This is a grate and a primary supply of the air, then incandescent coke, green coke, and these other flames. Okay. Now this there are various types of the overfeed strokers also. Different types of overfeed strokers are used for large capacity boiler installations where the coal is burnt without pulverization. So these are classified, the strokers are mainly classified into two types, that is traveling grade strokers and spreader strokers. So traveling grade strokers can also be chain grade type and bar grade type. So let us talk about all these strokers one by one in the next video.